Hello, you're in class right now, but here are some notes. This way, you can watch the notes back if needed at another time. So we're going to take notes 4 called the greatest common factor. And we have to first remember what a factor is. Factors fit into numbers. So the mistake that a lot of students make is that when they're trying to find the greatest common factor, they're thinking about numbers that are bigger. They're thinking about numbers that are more, and those are actually multiples. Like a multiple of 6 and 9 would be 18 because they both multiply to be 18. Factors are smaller. They fit into the numbers, and it's a number that can be divided into both numbers. When we're working with our greatest common factors, we have to know what the prime numbers are because those are the smallest, they're factors that can't be broken down anymore. And so this is just a list of prime numbers for you to have to reference if needed. I'm pausing so that you can write them down. Okay, and then our directions are going to say for these practice problems to find the greatest common factor. And I just want you to be reminded that the greatest common factor is the largest factor. That's why it's called the greatest and the largest. It's the biggest number that fits into both numbers. Both is what the common comes from. So when you find the greatest common factor, it's the largest factor or the largest number that goes into both of the numbers we're looking at. We're going to do 3 examples. The first is 12 and 18. Now, you might be a whiz at division, and you might be able to just know what the greatest common factor is right away. Some of you who might not be the best at division, mental division, are going to want to break these numbers down. So if you know the answer, awesome. But I would like you to pay attention to how we're going to find the greatest common factor. And to do that, we're going to make factor trees. We're going to break the numbers down. And so 12 can break down into it can break down into 3 and 4, or 6 and 2, or 12 and 1. There's lots of ways to break it down. I'll break it down into 6 and 2. And when I get to a prime number, remember we wrote down a list of the prime numbers right here? When we get to a prime number, I'm going to circle it because it means that branch is done. I can't break the 2 into any other numbers besides 2 and 1, but that doesn't change anything. Then I can break down my 6 because it's not prime. The opposite of prime is called composite. Composite numbers have factors in them. And 6 breaks down into being a 2 and a 3. So I can just write that out. 12 is equal to 2 2s and a 3. I always put them in order from least to greatest. So 2 times 2 times 3. And the cool part about this is if you multiply the factors, if you do 2 times 3, you're going to get 12. So when I say they're equal, I literally mean that they are equal to one another. Now let's do 18. 18, you could do 6 and 3 or 9 and 2. There's lots of possibilities. I'll do 9 and 2. Again, 2 is prime, so I circle that. 9 is composite, so I can break it down into 3 and 3. And 3 are both prime numbers, so I can circle those. Once all of my branches are circles, like stop signs, I know I have factored it completely, and then I'm going to write out the list. 18 is a 2 and 2 3s. So those are my factors. To find the greatest common factor, I'm going to circle any matches. Do you see how the 2 and the 3 here are matching? I mean, the 2 and the 2 are matching. They're the same number, as well as this pair of 2s. I'm sorry, those are 3s. Geez Louise. So I have a pair of 2s and a pair of 3s. To find the greatest common factor, I'm going to take one number from each group. One number from each circle. So I take a 2 and I take 1 3 and I multiply them together. 2 times 3 is 6. So 6 is my greatest common factor.